Okay, so I said in the last video that you shouldn't worry about memorizing properties of logarithm, because if you understand the exponential function, then you can just understand the properties of the logarithm. So let me just show you how you can derive one of these properties of the logarithm instead of memorizing it. So the property that I want to show is that log of a times b is equal to log of a plus log of b. And that's just, this is for any base, so let's just say it's base b. So let's recall, what does it mean, the definition of log. So if I have this function f of x is b to the x, and there's an inverse function which I call log. F inverse of y is log base b of y, and these are inverses of each other. So the exponential and the log function are inverses of each other. So what does this mean? This means that b to the x is equal to y if and only if, so is the same thing, is the same statement as log base b of y is equal to x. These are the same exact statement. So this is saying that if I take my b to the x machine and plug in x, I'll get y. If I take the opposite process, I plug in y, I'll get x back. And so now we can try to derive this property, right? So if I have log base b of a, this is going to be some number, which I'll call little a. Oh, actually, let's use a different letter. I'll call little w. And what does this mean? This is the same thing as saying that b to the w is equal to a. And if I have log base b of capital B is equal to z, what does this mean? This is the same thing as saying that b to the z is equal to capital B. Lowercase b to the z is equal to capital B. And so if I want to calculate log base b of a times b, if this is going to be equal to something, this is the same thing as saying that b to this something, question mark, is equal to a times b. But I know what a is and I know what b is. So a times b, using these two equations, a times b is exactly equal to b to the w times b to the z. And now using properties of exponents, this is b to the w plus z. And so I have b to the something is b to the w plus z, and so this something is w plus z. So this log base b of a times b is equal to w plus z, and w is log of a, and z is log of b. So this is exactly equal to log of a plus log of b. And so we've showed this statement, right? Log of a times b is equal to log of a plus log of b.